This is the key to section 4.1 part 1, and in this section you're looking at graphing exponential functions. Now again, these are exponential functions, and you have to remember that one of the things about exponential functions is that the domain, the x value, I can use any real number for x and I'll get a y value back. So regardless of whether the real number is rational number or an irrational number, it does not matter. I will get a y value back. So the domain you're going to see is going to be all real numbers. You're going to say negative infinity to infinity, always. So the domain for all exponential functions is going to be all real numbers. Okay, now the range is not going to be all real numbers. It's going to depend on where the horizontal asymptote is, on what it is, and whether the graph is above or below that horizontal asymptote. All right, so the range is not all real numbers. It's only the domain. Okay, so the domain is the only part here that's going to be all real numbers. Okay, now let's talk about how to find the horizontal asymptote. So all exponential functions have a horizontal asymptote. And so if you recall, if I look at the general form of an exponential function, so let's say I have f of x equal a, let's call it b to the x, b for base, b to the x plus c, some constant, okay? So this constant right here, this constant is your horizontal asymptote. All right, so where y equals c is the horizontal asymptote. Now you may say, well, why did I say y equal? Because remember the horizontal asymptote, because the horizontal asymptote is a horizontal line, and we denote it as a dotted horizontal line. And remember, all horizontal lines have the equation y equal a constant. Okay, so just some things you have to remember from previous lessons and previous courses. So in this case, if you look at f of x equal 3 to the x, do you see that f of x equal 3 to the x is the same thing as saying f of x equal 3 to the x plus 0? You'll agree with that, right? So therefore, I found my horizontal asymptote. So my horizontal asymptote is y equals 0. Now remember, you can't just say 0. Okay, so it's a horizontal asymptote. It's a line, so you got to indicate it as an equation. So you have to say y equals 0. Now remember, when we denote the horizontal asymptote, when we actually show it, we show it as a dotted line. Now do you see that y equals 0 is the x-axis? So y equals 0 is the x-axis. So I'm going to go ahead and put a dotted line on the x-axis. So I'm going to go ahead and do this. Just kind of like this. Okay? Now what that means is that at some point the graph, whatever the graph does, it will go towards the horizontal asymptote, kind of get closer and closer and closer to it, either like this or like this, okay? Or if it's underneath the horizontal asymptote, if it's below the horizontal asymptote, it could do this or it could do this, okay? So there's several possibilities that could happen here depending on what the function is, okay? All right, so I found my horizontal asymptote. I put a dotted line to represent it. Okay, you had to do that. Now let's talk about the y-intercept. The y-intercept, now remember, since the domain's all real numbers, that means I can use any value for x. Well, remember how to find the y-intercept? To find the y-intercept, you let x be 0. And so therefore, in 0 in the domain, x equals 0 is in here, right? Because the domain's all real numbers. So to find the y-intercept, you let x be 0. So what I'm indicating here is that all exponential functions have a y-intercept because the domain's all real numbers. So to find it, I just go to my function and I let y equal 0. I'm sorry, x equals 0. So I get y equal 3 to the 0, which is 1. And it didn't say to indicate it as an ordered pair, so I'm just going to go ahead and write the y-intercept is 1, or you can say 0, 1. Does not matter. Okay? So the point being is this. So do y'all agree that 0, 1's right here? So that means that the graph is above the horizontal asymptote. Now all I need is a couple more points, because I want you to do 3 points, to draw a better part of the graph. Okay? All right, now, one of the things that you learned as we went through these lessons was, see where the base is 3? The base is 3, you see that? And the exponent's x, the base is 3. So that means that your function is an increasing function. I'm going to write this down. Since the base, which is 3, and that's greater than 1, okay, greater than 1, then f of x is an increasing function. All right, you didn't have to know that for this worksheet. I mean, you could have forgotten all about this and still have done this worksheet. But it does help to know that, so that way if you make a mistake and you do this, you know something's wrong because it doesn't do that. Because we just said that since the base is 3, if the base is greater than 1, it's an increasing function, so it needs to do this, right? It needs to do this. Okay. So I'm going to use a t-table, and I need 2 more points. I already found one of them when x is 0, so let's say x is 1. If x is 1, I get y equal 3 to the first, which is 3. I'll agree. So 1, 3 is here. So you see it's going to be an increasing function. All right, but remember, you got to make it look, you have to make it look like an exponential function. If x is 2, I get y equal 3 squared, which is 9. So 2, 9 is right here. And that's enough. So then I know that on this side, the graph gets closer and closer and closer to the horizontal asymptote without touching it or crossing it. See, these values, as I go to negative infinity, these values are getting smaller and smaller and smaller and getting closer and closer to 0. And then on this side, it rises rapidly, hence the word exponential. It rises rapidly. Okay, so that is your function f of x. Now, to do the domain, just kind of do it like you did with previous graphs. You take your ruler, and you know that you start touching a graph, so to speak, at the horizontal asymptote. All right, so the horizontal asymptote is what y value? Well, that's 0. That comes from here, right? 0. So you're going from 0 to infinity. Now you have to remember, though, that that's a horizontal asymptote. I cannot say bracket 0, because if I say bracket 0, that means that at some point I'm going to get my y value being, there's a y value in the graph that's 0 and there's none. It gets closer and closer to 0. Okay, it gets closer and closer to 0, but it never is 0. So I have to say 0 to infinity, from 0 to infinity. Okay? All right, so that was number 1. Okay, and then number 2. So the difference between 1 and 2 is, if you see this is 3 to the x and this is 3 to the x minus 6. All right? So again, you know right away what the domain is. What's the domain of all exponential functions? The domain of all exponential functions is all real numbers. I'm going to say negative infinity to infinity. Okay? And I know the horizontal asymptote. The horizontal asymptote is this constant right here. So, but remember, you got to say y equals. So that's y equal this constant, which is negative 6. Now that means that one part of the graph, the one that looks like it's flattening, but it really isn't, that one part of the graph is going to get closer and closer to this horizontal asymptote. That's what that means. In fact, I can go ahead and draw the horizontal asymptote, y equal negative 6, y equal negative 6. We're going to draw a dotted line. So here's y equal negative 6 right here. See it? Right there. So I'm going to draw my dotted line to represent that horizontal asymptote. And I'm going to get this. Okay? Draw a dotted line to represent the horizontal asymptote. And so, all right, so there's my horizontal asymptote. All right, now, again, well, let's go ahead and find, remember, since the domain is all real numbers, all exponential functions will have a y-intercept. So let's go ahead and find it. To find the y-intercept, you got let x be 0. And so I get 3 to the, so y equals 3 to the 0 minus 6. So that's 1 minus 6, which is a negative 5. All right, so there's my y-intercept. So that means that the graph is going to cross the y-axis at negative 5 right here. So now I know that the graph's going to be above the horizontal asymptote. Now either it's going to do this, it's going to increase or it's going to decrease. Well, look at the base. The base is 3, right? Since 3 is greater than 1, so since the base is a number that's bigger than 1, it's going to increase. And you're going to see this in a little while, that this will increase. All right? So let's go ahead and figure out 2 more points, because remember, you need 3 points. So let x be 1. If x is 1, I get y equals 3 to the first minus 6. So that's 3 minus 6, which is negative 3. All right, so 1, negative 3 is right here. So you see it's going to increase, right? I need one more. If x is 2, I get y equals 3 squared minus 6, 9 minus 6, which is 3. So I'm plot the point 2, 3, which is here. And so I get something that looks like this on this side. Make sure it looks like an exponential function. It rises rapidly, something like that. And on this side, I didn't do a very good job with this, but on this side, it gets closer and closer and closer to the horizontal asymptote without crossing or touching it, okay? So there's the graph of f of x. All right. Now, let's talk about the range. So remember the range, or is what are these y values on this graph? Remember, these y values here are getting closer and closer and closer to this horizontal asymptote, and that's negative 6. So my y values are getting closer and closer to negative 6, right? So that's going to be the smallest. But it never is negative 6. So it's getting closer to like negative 5.9999999 and so on, right? So you're going to say parentheses negative 6 all the way to infinity. Okay? All right, so that was the key to worksheet 4.1, part 1.